last time actually we introduced the embedded Linux system because for um, Raspberry Pi, because Raspberry Pi is a kind of embedded platform, which means even though we use Linux system for Raspberry Pi, but we cannot use the the normal edition. So actually the embedded version of Linux is used in Raspberry Pi. Okay? And even though it's embedded Linux, actually from user point of view, we don't see much difference. It's still Linux. So all those Linux, especially if you have experience with Ubuntu, then you don't see any difference. You know you, they use the same file system, they use the same commands, so everything is very similar. So if you are very if you have experience with uh, Linux, actually using the embedded version of Linux in uh, Raspberry Pi is not a big deal. Okay. Last time actually we just briefly introduced certain things about the Linux system, and in fact, for Linux system, there are a lot of most of the time actually we use command line to do something. It's a little bit different from Windows. Um, Windows actually provides a very nice user interface. It's very easy to maintain the system as a user. It's very easy to it's the user interface is very friendly. But the bad thing is by Windows tends to do a lot of things for you. Sometimes you if you want to control the system, um, Windows doesn't provide certain freedom for you. Okay, so for Linux, actually, it's everything you control it. The system doesn't do things for you. So that gave users the freedom to do whatever they want to do. So that's why if you go to if you go to those research-oriented universities, a lot of time actually students work on Unix or Linux systems instead of using Windows. Okay. So just give you a background about Linux system. For Linux system, we can do a lot of things. We can, for example, we can soft links, hard links. This slide actually shows how can we link, um, make a link for a file, because a lot of time actually when we install a file in certain directory, we don't want to let user to manipulate that file. Instead, you can create a link to the original file. So when users manipulate the link, that doesn't change the original file. So that's why, a lot of time we create links. Okay, so that's I mean there are two kinds of links: soft link, hard link. I last time I already showed you one example of a file link. Okay? So you will see a lot of file link if you go to a Linux system. And there are a lot of Linux commands. Here we list several examples. There are tons of Linux commands. You can do a lot of things. For example, you can sort a file by using sort command. Okay, you can count the word in a file by using this WC command. All of these commands actually can be used on files to do certain things. If you don't know how to use those commands, you can just, for example, if you don't know how to use sort, you type in sort, uh, space dash H. Let me show you. Um, Wait a minute. Let me try to log into the Raspberry Pi. All right. Okay. So you can see this is in Raspberry Pi, and actually, yeah, Linux system. For example, if you want to know how to use the sort command, what you do, you just type in sort and -h, and it will show you all the help information. Doesn't do that. It's supposed to. Or you can, what you can do, you can use man. So yeah. So when you type man sort, man means menu. Okay, you want to see the menu. So if you type in man sort, it will show you the help information to to teach you how to use this command. Okay, so for all kinds of commands, you do the same thing. You can, like for example, if you want to know how to use a WC command, you just type in man WC, and you will have the help menu. Okay, so that's what you can do. Okay. All right. Okay, so I showed you some Linux commands, and there are lots of Linux commands. For example, you can use echo to display certain information. The cat command is used to facilitate you in joining two files, concatenate. That's the meaning together at this command line. And tar actually is a software package. It's a command actually. It can archiving, create a archive package for you to, for example, if you have several files and you want to compress those several files into one single compressed package, then you can use this tar command. Tar command is used to combine files into one single compressed file. Okay, and once you package all those files into one single file, then you can use zip, gzip to compress it. Okay, so those are some common Linux commands. And in Linux system, actually, we do have a Linux process. That means one process in the Linux system means an instance of a program. Okay, so Linux system actually is a multi-process or multi-task system, which means in Linux system you can execute multiple programs, execute multiple instance of programs. Okay, so each instance of a program is called a process. So to check what kind of process is running on your system, you can use this ps command to list all the processes currently running in the RPI, okay, in the Raspberry Pi. And Linux is a multitasking operating system, like I said, that enables you to run processes in the background while using a program that is running in the foreground. Okay, so how to run a process in background? You can do things like this. So like you can use PS to show what kind of um, processes are executing in the system. So here you see for this Raspberry Pi, actually I have only two processes, one bash, that's the kernel bash of the system, and then PS, that's the process I just executed. So basically there are no process running right now. And you can run a program in foreground. Foreground means when you run a program, you know, it's running in the foreground. That means you can see it. And if you don't want to run a program in foreground, you can run a program in background. So to run a program in background, that means it won't, you know, if you run a program, for example, if you run a program in foreground, then only when your program completed, then you can use this window. Okay. Sometimes you want to run the program at the same time, you still want to use this terminal window. How to do that? You run the program in background. Okay. So for example, you can, if you want to run a program, sort, you know, whatever, something into the background, you just add the command with ampersand sign. Once you do this, you press enter, this, you know, process will be running in the background. That way, the program is running, and at the same time, you can still use this terminal. Okay, so that's the, you know, the benefit for running a program in background. That's why, you know, this is the freedom provided by the Linux system. So Linux system actually is very very convenient, very nice actually for a computer system. Okay. And another very useful tool for Linux system is Git. Okay. And nowadays everyone knows there is a website called GitHub. So the GitHub actually is built based on this Git system. Okay. So Git actually is a system that enables you to track changes to the content of a software project as it develops. So that means several software or multiple software developers, they can work on the same project, and they can by using the Git system, they can maintain the you know, the version, the development version of the software. Okay, so in fact, so Git is a distributed version control system. This figure actually shows you the basic Git workflow. So you can see actually in your working directory, you can use git clone to download the, you know, the whole repository of the software. For example, you know, there are a lot of software shared in GitHub. So for example, if you want to work on a specific software package, what you do, you just use git clone, and, you know, followed by that remote URL, you can download the whole software package from remote location to your local working directory. Okay, so, and then you can work on your you know, your local directory, and then once you commit the changes of the development, you can push back to the remote location. Okay, so that means you know, as a researcher or a programmer, you can provide contribution to the software development. Okay, and the Git system actually maintains the development version of the software system. Okay, so as long as you follow this Git workflow, so that way, you know, different people, they can collaborate together to make provide contributions to the development of a software package. Okay, so that's for Git. And to run the Git system, you can just type in. No, not this one. All right, so what you do, you just type in git clone and followed by the website, like HTTPS, GitHub, something, yeah. Something, okay? So once you have this, type in this command, you press enter, and that will clone everything of that software package to your local directory. And then you can work on your local directory, you know, add some new things to the software and maintain the, commit the change of the version, and then you can push back to the remote location. And that way, as a developer, you provide your contribution to the development of the software package. Okay, so the Git system actually make this very smooth and make sure that everyone has the the correct documentation about the software development. Okay. All right, and in fact, sometimes you may want to use Linux system in your desktop. And so what you can do, for example, if you have a Windows desktop and you want to also use Linux, what you can do actually, you can use desktop virtualization. So desktop virtualization actually enables a single desktop computer to run multiple operating system instances simultaneously. And so you can, in virtualization, in fact, there are usually 2 or more distinct operating system instances. Okay? So that way, you know, by using only one computer, you have different operating systems. Okay, so that you can work on different applications. You can work on different environments. So that actually provide a very good, opportunity for you to work on different projects, different applications by only maintaining one single computer. Okay, and so this is one example of running Raspberry Pi, the Debian Linux system as a guest operating system on a Windows host machine. Okay, so this actually is a virtual operating system, virtual machine, by using this VirtualBox software. Okay, so you can try this using VirtualBox to see, to install a virtual system for you. Okay, so that way you can work on this Raspberry Pi system without leaving the Windows environment. Okay. So in this chapter, actually, we just give you a very basic introduction about the embedded Linux system, and we actually describe how can Raspberry Pi boost the Linux system. So if you remember, we introduced there are several steps. Okay, and also we introduced some basic command line commands for Linux system. We also introduced the kernel space, user space, and system initialization with using a systemd system. Okay? And so you can see this chapter actually just cover all those basic concept about embedded Linux system. So if you want to get familiar with embedded Linux system, like we saw in the last slide, you can use VirtualBox to install a Debian embedded Linux system in your Windows machine to to have a basic understanding about this embedded Linux system, and you can practice that. Okay. In fact, by using Git, we can download source code from remote location. Okay. Specifically, in fact, this textbook, the textbook we are using right now, the author provide all the source code on GitHub. Okay, so if you want to play with all the source code, you can use Git to clone all the source code from the GitHub location. Okay, so the GitHub location actually is in the the book. Let me see. Yeah, it's here. So the book actually is here. Let me see. Can you see the book?
Yes.
You can? Okay. Let me see. I believe it's in the front. Anyway, I know there are some websites listed in the textbook. Okay. But anyway, if you can, what you can do, let me show you. You can search for this textbook. Okay. It's exploring Raspberry Pi. Okay. If you go to, let me see. Okay. So, for example, when you search for Raspberry Pi for exploring, you will go to the website. Okay. So once you come to this website, you can you have all those yeah, you see here. It provides this GitHub link, and what you do, you can download everything by using the Linux system. So you can, let me see, I can go to Templar. Once I'm in this directory, I can download everything to here by execute this line. You see git clone, and then the website for the software package. Once I press enter, you see it's downloading the package. Okay. Okay. So you can see all the software, all the source code is downloaded. Okay. So to check what kind of source code we have, you can go to this directory, and you can see all the chapters are here, chapter 3 all the way to chapter 15. And for example, if we go to chapter 3, you see we have this C program, and then there is an executable program here. And if we go to, for example, chapter 10, let's see. Okay, so you can see all those files are here. Okay, if you, for example, if you want to check the stepper motors files, there are stepper motor files, the CPP. In this textbook, actually, the author mainly use C++ program, but for us, we like to use Python. I believe certain chapters, the author also provide Python programs. But anyway, we will focus on Python. Okay. All right. Okay, so this is for chapter 3, and in chapter 3 we just briefly introduced the embedded Linux system. Okay. Any questions? No question? All right, so let's see. All right, so once we finish chapter 3, let's go back to chapter 2. So chapter 2, actually, we will introduce the software of Raspberry Pi. Okay. If you came late, can you please type in your full name into the chat area, because I need to take attendance for class. Thank you. Okay, so for chapter 2, we will talk about the software of Raspberry Pi. Okay, so all right, so in chapter 1, we talk about the hardware of Raspberry Pi. Okay, for hardware, we know there are several kind of models, certain hardware specifications, like we have the CPU, the controller of the Raspberry Pi, and also we have GPIO. The GPIO actually is a kind of interface between the Raspberry Pi and the external devices, which means you can connect external hardware devices to the Raspberry Pi through the GPIO. And then there are some other hardware chips, like the memory, all those interface controllers, many things. So to make this system work, definitely we need software. Okay, for any computer system, that's true. You have to have hardware and software. So for Raspberry Pi, we know the operating system is the embedded Linux system. We already saw that. Okay, and so for this embedded Linux system, to install to Raspberry Pi, you can go to this location to download the Linux system image, and you can download this system image and write it to a SD card using image writer utility. Okay, but actually, most of the time when we purchase Raspberry Pi, it comes with SD card, and that SD card is you know the Linux distribution image is already written to it. And what you need to do is to just install the Linux system. Okay, so so most of the time you don't really need to download this image and write the image to SD card using this image writer utility, but you want to know how to do it. Okay, so this is the way that you can install the Linux system distribution to your SD card, and then for the first time when you turn on the power of your Linux system, you have to do the install procedure. Okay, so and once you install the Linux system to your Raspberry Pi, remember for Raspberry Pi, actually there is a HDMI port, which means you can use a HDMI cable to connect your Raspberry Pi to a monitor. Okay, and also there are 4 USB ports, which means you can connect your USB keyboard and USB mouse directly to the Raspberry Pi. If you do that, in fact, you can use mouse and the keyboard directly connect to the Raspberry Pi to input, you know, everything, and then you can use the monitor to display the Linux system. You know, but sometimes, most of the time, actually, because we know Raspberry Pi is a kind of Linux system. Embedded system. Embedded system means you know, you put the Raspberry Pi into somewhere, and then for example, if you use a Raspberry Pi to work as a door opener, you don't expect to connect your door opener to a you know, to a monitor and also a mouse and a keyboard. That's impossible, right? For a door opener, you attach a monitor. That's not you know, practicable. Okay, so so what we do actually, instead of most of the time as a developer, instead of connect your Raspberry Pi to a monitor and to a keyboard, to a mouse, instead you want to connect your laptop or a desktop to your Raspberry Pi through a network connection. Okay, so to connect, for example, I can use my laptop. This is my laptop. I can use this laptop, connect to my Raspberry Pi remotely using network connection. Okay, so to connect your laptop to Raspberry Pi remotely using network connection, first thing you have to do is to identify the Raspberry Pi's IP address. So how to find out the Raspberry Pi IP address? First of all, you have to connect your Raspberry Pi to your network. Okay, for example, in my home, I connect my Raspberry Pi to my home router, and also my laptop is also connected to the home room, my home router. So they are in the same network, and so my laptop can remotely access the Raspberry Pi using the Raspberry Pi's IP address. So how can I know what is the IP address of the Raspberry Pi? There are several ways. You can use a web browser. You can use a port scanning tool. You can use zero configuration networking. You can use a USB to TTL serial connection. Okay. Let me just show you the first one, how to use a web browser to find out the IP address of your Raspberry Pi. Okay. For example, or in my case, okay, what I do actually oh no. I can go to the router. This is the IP address for my router. Most of the time, actually, for a home router, this is the IP address. Okay, so once I go to this IP address, it asks me for the username of the so my username is this, and the password. So you can see this is the interface for my router, and I can go to here, attached devices, see all the devices attached to my router. Okay, so you can see from here, you can see Raspberry Pi, and I know Raspberry Pi has the IP address this 192.168.1.33, and so that's the IP address for my Raspberry Pi. Okay, so once I know the Raspberry Pi IP address, I can log into it. So to log into Raspberry Pi from my laptop, this is my laptop, and Raspberry Pi actually is not connected to my laptop. It's connected to the router through wireless, Wi-Fi. And my Raspberry Pi actually doesn't connect to any monitor, any keyboard, any mouse. Actually, by using this way, I can use my laptop's monitor, keyboard, and mouse to control the Raspberry Pi remotely. Okay, so to log into the Raspberry Pi, first of all, you have to enable the Raspberry Pi SSH. Okay, to enable the Raspberry Pi SSH, I will show you later. You can log into Raspberry Pi by using SSH. You have to have SSH installed in your laptop. Okay, so I have SSH and then pi at 192.168.1.33. So that's the IP address for my Raspberry Pi. Okay, once I press enter, it will ask for password, and pi, this pi, that's the username for Raspberry Pi, and the password for Raspberry Pi, the default password for Raspberry Pi is Raspberry. Okay, so I just type in. So once I type in the password, I can log into the password to the Raspberry Pi. So here, you see, this window is in my laptop, but I'm remotely in the Raspberry Pi. Okay, so once I enter Raspberry Pi, I can do whatever you can do in a Linux system. You can use ls to list all the directories and files in your Raspberry Pi, and also you can check the root directory of your Linux system. You see, for the root directory, there are many kind of directories, like a user. This user actually, for every Linux system, there is a user account. All of those user installed, software, library, include files are saved in this directory. And there is a home directory. So all those user accounts, they are in this home directory. Okay, for example, if we go to the home directory, you can see there is, because my Raspberry Pi, there is only one user account, which is Pi. That's the default user account in Raspberry Pi. Okay, and so this is the way that you can remotely log into the Raspberry Pi. And like I have said, you need to enable the SSH first in your Raspberry Pi. So to enable your SSH, so that means, okay, before you can remotely log into your Raspberry Pi, you need to set up the Raspberry Pi by connecting the Raspberry Pi to a monitor and a mouse and a keypad. Okay, so you have to do that before you can remotely log into your Raspberry Pi. Okay, so that means you have to make sure that you connect your the first time, the very first time, you connect your Raspberry Pi to a monitor, to a mouse, to a keyboard. Okay, and then in the first time you run, you set up the Raspberry Pi, you will see a window like this. You will see a window like this. Okay, so in this window, you can set up all those things like change user password, network options. So, for example, you see you can do everything, and then boot operation options, location options. So you see you set up the interface options. So, for example, for the SSH, you want to enable it. Okay. Camera, if you do have a camera connected to your Raspberry Pi, you want to enable it. Okay. So that's if you have a I2C, I2C SPI devices, you have to enable this. Okay. So so all these things you can configure here. Okay. And look at this this command. I do have a sudo. Okay, this sudo actually makes sure that you do those root account privilege. Okay, so sudo actually give you administrator privilege. You can do a lot of, if you don't type sudo, a lot of time actually. For example, you cannot install anything to Raspberry Pi without using sudo. If you want to install something to Raspberry Pi, you have to use sudo. Because only sudoers can have the privilege to install certain things. Actually, sudoers is very similar to the administrators in an operating system. Okay. Okay. All right. So this is the way that you can find out the IP address and also, using the IP address to log into the Raspberry Pi. Okay. Okay. So we also, I just show you one method that how you can get the IP address of Raspberry Pi, and for the other, I didn't check with the other tools, but you can explore. Okay, you can use a scan tool to scan the IP address port, or you can use Ethernet crossover cable. So that means you can connect the Ethernet crossover cable to your Raspberry Pi and your laptop, and that way your Raspberry Pi can directly connect to your laptop through the Ethernet cable. Okay. The problem is if you don't have Wi-Fi for your computer, then, and also if you only have one single Ethernet cable port, then you cannot connect your computer to the internet. But nowadays no computer doesn't have Wi-Fi, so that's not a problem. Okay? The easiest way to connect your laptop to Raspberry Pi is using the IP address. Use the SSH method. Okay, so SSH is used to to remotely log into the Raspberry Pi, and if you want to, for example, if you want to send a mail to Raspberry Pi from your laptop, or get a mail from your from the Raspberry Pi to your laptop, what you can do, you can use SFTP. Okay, you do the same thing, SFTP pi at 192.168.1.33. That's the IP address. to use the same password, and you log into the Raspberry Pi. And SSH means you remotely log into the system. You can do whatever you do, the same as you are directly inside of the Raspberry Pi. SFTP is for you to do file transfer. That means if you want to, for example, if you can write a program locally in your laptop. Once you finish the writing of the program, you can upload your file from your laptop to Raspberry Pi. So how can you do it? Use FTP. Okay. So once you log into the FTP, you can use put the file to Raspberry Pi to upload your file to Raspberry Pi. Or if you have a file inside of the Raspberry Pi, you want to, fetch it from Raspberry Pi back to your local laptop, you can use get. Okay, so get the file back to the laptop. Okay, so that's the ways that you can do a file transfer between your laptop and the Raspberry Pi. Okay, so that way you can see this way actually make it very convenient for you to debug or to upgrade your system. For example, if you are using Raspberry Pi to make a home security system, okay. For example, you connect a camera, for example, a surveillance camera to your Raspberry Pi, and you put your Raspberry Pi and surveillance camera into a small box, and you install the small box somewhere. Not very easy to reach. Okay, it's impossible to connect a monitor and keyboard or a mouse directly to the Raspberry Pi because it's inside of a box and it's located somewhere not easily to reach. In the future, if you find that your system has some bug and you want to upgrade your system, you don't really need to take it off and then connect everything back to monitor to something. What you can do, actually, you can write your program in your laptop, and then you just remotely upload your file to the Raspberry Pi. Okay, so you don't need to touch the Raspberry Pi. The Raspberry Pi is still installed, in the location that it's hard to reach. Okay? As long as you have a internet or network connection to the Raspberry Pi. Okay, so that way, you don't need to move the Raspberry Pi. You can just do everything in your laptop, and then you just upload the file to Raspberry Pi or download the file from the Raspberry Pi. It's very convenient. Okay, so that's something that you want to practice for the Raspberry Pi system. Okay. Okay. All right. So this is a figure showing you how can you connect the Raspberry Pi to a laptop using Ethernet crossover cable. Most of the time, actually, we don't need this because our laptop has a Wi-Fi. The Raspberry Pi has a Wi-Fi, so you don't really need to have a physical cable to connect these two. You just use the Wi-Fi because both of these two they connect to the routers through the Wi-Fi. Okay, so they can communicate like what I have. I can check the IP address for the Raspberry Pi, and then I just use SSH to remotely log into Raspberry Pi and control the Raspberry Pi. Okay, so that's something that you want to understand. Okay. There are some other way that you can communicate with the Raspberry Pi. You can use a serial connection over USB to TTL, and also network connection. But the connection I showed you is very convenient. You just use your Wi-Fi, connect your, make sure that both your Raspberry Pi and laptop connect to your router, okay, in the same network, domain. Okay. So this is still the you can use serial connection with the USB to TTL. This is what I do. I just showed you connecting through a secure shell. That's the SSH. Okay, so you can use an SSH terminal client to connect to the SSH server that is running on port 22 of the Raspberry Pi. So Raspberry Pi actually has a SSH server, but like I've said, by default, SSH server is disabled on Raspberry Pi. Okay, so before you can make SSH connection to Raspberry Pi, you have to, you know, you have to make sure that the SSH is enabled. Okay, so to enable the SSH, remember I showed you, you can go to the configuration. In the Raspberry Pi user interface window, you can select, you can click the preference of Raspberry Pi to to make the change. You can enable there. You can enable the camera. You can enable the SSH. Once you enable SSH, the SSH server on the Raspberry Pi is enabled. Okay, so once you enable it, then you can log in remotely to Raspberry Pi and execute command like I did. Okay, and then you can use SFTP to do the file transfer. I already also showed you how to do that. You use SFTP. You cannot do SSH and SFTP at the same time. Okay, but you can open two windows. One window you use SSH, connect to the Raspberry Pi. Another window you can use SFTP to remotely log into Raspberry Pi and do the file transfer. Okay, so that's what you can do. Okay, by using SSH, a very convenient way, you can use PuTTY. Okay, PuTTY is a software package. You can download PuTTY freely and install PuTTY into your Windows. And PuTTY is it has a very nice user interface. Okay, so so inside of PuTTY, you can provide the IP address of your Raspberry Pi and also the port number. We know the port number is 22. Okay, so this give us an example of PuTTY. So in the PuTTY, you see you have to provide the address, the IP address. For my case, it's 192.168.1.33, and port number is 22 because for every Raspberry Pi, they use port 22 as the SSH. Okay, so you have to select SSH, the connection type, and then you can start the connection. And once you start the connection, you will see a window like this. Okay, so this is I didn't use PuTTY, but I use SSH because I already installed SSH application in my Windows, so I don't need to use this PuTTY window. Okay, so and you can also use the Chrome application. Chrome, is developed by Google. They also provide this kind of SSH application. I didn't try this. If you are interested, you can try this. Okay, so that's but PuTTY is PuTTY is very convenient, very easy to use software package that you can use to make this connection. Okay. So to control the Raspberry Pi, in fact, I already showed you there are a lot of Linux commands, and also the file system commands. So let me show you again. So I have to get out from the SFTP, and then then I have to. So you can see I can very easy to what you can do if you want to find out all those previous commands. You just use the key. I mean the arrow key. Okay? You use the up arrow to find all those command that you used before. Okay? So I just you don't need to retype in the command again. You just use the arrow key to find out to find all those previous executed instructions. So this SFTP I'm gonna use. I need the SSH. All right. So once you're inside of SSH, you can do whatever you do. You know, just use, for example, the very popular Linux command is ls, is to list, you know, what kind of files or directories you have in your system. Let's see. Do you have any questions up there? Do you have any concern, any questions? Okay. All right. So so you can see this is by using ls, you can list all the files and directories. If you want to list, you know, everything, the detailed information of all those files and directories, you can use ls space -a. Okay, that means you list all the files, including those hidden files. Okay, so you can see if there is a dot in front of a file name or directory name, you cannot see it by only using ls. Okay, but if you use ls -a, that means you list all of the files, all the files. Okay, if you want to list all the detailed information of the files, use ls-l. Okay, so that you see this cv2.so, and you have an arrow here. That means you know, this file is a link file. So this link file actually is not the real file. The real file is here. This is the real file. Okay, so the real file is here, and this is only a link file, which means whenever the system sees this file, it will go to this location to get this file. Okay, so that's what we mean is a link file. So to make a link file, remember you use ln to make link file. So to know how to use ln, you type in man ln. You see all the help information shown here. You can learn how to use it. Okay, and to know where you are right now, you type in pwd. Okay, so pwd, you know, give you the current directory. And so right now I'm in home pi directory. You use pwd. Okay, and you can use who am I. It shows you the account name. Okay, so right now, because I'm in the account of Pi, this is my account name, and also you can use a date to show the current date. Okay, so there are a lot of like uptime. Okay, so it shows you how long the system has been running. Okay, so this is the time that for the system. Showing you how long. Okay, so there are all kinds of commands for Linux. Okay, and also you can by using ps to show you you know, the shell that you are currently using. So this is the shell I'm currently using. It's bash. Okay. Remember, for Linux, actually, it has a shell. Okay. So different Linux, they have a different shell. So like, you know, you may have Ubuntu, you may have CentOS. So there are all kinds of Linux systems. Okay. All right. And then there are other commands. If you want to move to another directory, you use cd. If you just type in cd, it will, you know, just go back to your home directory. And your home directory in Raspberry Pi is Pi. It's home Pi. That's your home directory. Okay. So for example, if I go to the root directory, I have all these root you know, directories. And if I want to go back to my home directory, which is home Pi, I don't need to type in cd home Pi. I don't need to do this. I just type in cd, and it will go back to your home directory. You can see my home directory right now. Okay. So, and also, if you want to find, so for example, if you want to go into this documents directory, okay, what you do, you type cd space and do. You don't really need to type in the whole thing. Once you type in doc, then you followed by a tab. The tab will automatically fill in all those remaining letters. Okay. So, for example, if you just type in do and you try to use the tab, it won't do anything. But if you type in the tab again, it will give you the two options. Okay. So it shows you there are two directory has the same starting do. So you have to type in one more word to differentiate them. Okay. So for example, if you want to go to download, you have to type in dow. That way you separate the download from documents. And this way, when you press the tab again, it will fill in all those remaining letters for you. Okay? You don't need to type in everything. I mean, this is for a very short directory name, it's okay. But for example, if we want to go to this OpenCV something, this is very long. If you want to go to this directory, if you have to type in everything, that will take you know, some time. Okay, but what we can do, you just type in cd open, and then press tab, and then type in one more character, press tab. Boom, that's it. You don't need to type in the rest of you know, letters. So this way you can save a lot of time. Okay, so this is just one you know, trick for you to manipulate within Linux system. Okay, and to make a directory, you can use mkdir tt. For example, tt is my directory name, and then you can see in this directory, I made a new directory tt. Okay, so if you want to remove this directory, you can type in rm -r. For directory, you want to put a -r because -r means recursive. If you just want to remove a file, you don't need the -r. You just rm file name. But if you want to remove a directory, you want to you know, use rm -r to remove recursively remove the directory. Okay, so this way you can see the directory is removed. Okay, and if you want to copy something, you can use cp. For example, cp, you can copy the whole directory of a temp to tt, for example. Oh, no. Okay, let me see. Let me do this. cd, and you can copy the previous the, you know, the up level directory to here. This way you have a image directory in this. You copy the image directory from the upper level to here, okay? And you can remove it by using RM. Okay. So you can see, and you can move a file by using MV to move a file. You can use a touch. You can more. You know, there are a lot of file system commands. Okay. You can find all those file system commands in the slides as well as in the textbook. Okay. All right. Okay. So this slide actually shows us those basic file system commands. You can see we have all these basic file system commands, and also there are some shortcuts like you use upper up arrow to find those previously executed commands, and you use this tab key to you know, to find to fill those file name without typing everything. Okay, and there are some other shortcuts for the Linux system. Okay. Let's see.